So these are from section 10.3, and these are just graphing, and we could use our graphing calculator, or we could just figure them out if we don't need it, and just sketch the graph. That's all they wanted to do. It says graph the set of points whose polar coordinates satisfy the given equation. So number 5 was r equals 3, so the radius is just 3. I set up my window like this. So if I'm going to graph r equals 3, the radius is 3, then it's just going to go out here 1, 2, 3. And I need a circle. It's just a circle because the radius is always 3, so that's not too bad. So I just have to find a circle that fits there. I got a little template here I usually use, so this don't have a compass with me, so I put this template here. And looks like this one here is going to work. So something thereabout should work, so we can just sketch it like this. R equals 3, so that means just as a circle, all the radius is always 3. It's not too bad. And the next one is r squared equals 4. Well, if r squared equals 4, the radius is 2, so that's just going to be a smaller circle if I use the same window. R squared equals 4, that implies that just r equals 2. We need something like, I guess that looks pretty close right there. So those are kind of easy. And number 9, the absolute value of theta is pi over 6. That means theta equals positive pi over 6 when it's negative, negative pi over 6 when it's negative. So just plus or minus pi over 6. So pi over 6 is about a 30-degree angle, so I can just draw a couple 30-degree angles. And this looks like, that's about 45, so it looks like 35, something like that. So I think we're going to draw, and that's the positive, and then negative would also be something like this, I guess. Always 30-degree angle, so something like that would work. So that's not too bad. And then number 11, it says find an appropriate window and use a graphing calculator to produce the polar curve, and then sketch the complete curve and identify the type of curve by name. So you have your polar gallery to look at. So let's try this first one here. It looks like it's in the form of cardioid. So let's just graph it. And this is going to be r equals, so we go into the polar mode. Don't forget to put your mode in polar. And 1 plus cosine. Oops, cosine. And then graph. And then my window, I picked my window over here, and they wanted to be, this one would probably work negative 3 to 3 and negative 2 to 2 for the y. So we graph this, and looks like we have, yeah, that looks like a cardioid. It's kind of like a heart. So we sketch that. Now I can kind of sketch this with kind of like a circle. It's part of a circle. It goes through 2 there. But it comes around, so it's kind of like something like this. It's going to be, when I do these cardioids, I kind of do them something like this. I start with a circle, then I bring it down around so it comes in like this. It has a little dimple in it like this. So that's the way I can get kind of a decent looking cardioid. Kind of a ghost line here. And that should suffice for number 11. Okay. So it was a cardioid. C-A-R-D-I-O cardiac, kind of like a little heart, so to speak. Okay, so that's your cardioid. And those forms, where they have the polar gallery over there on page 556, that's over there. And they've got the kind of the parameters on the general form, so that's your good old cardioid, popular curve.